In this video, I'm going to be talking about soldering and some of the types of pipe, specifically hard-drawn pipe. Now, the soldering is the act of joining two pieces of metal together with a soft metal filler alloy. The lowest temperature operation that involves melting metal is soldering. Low pressure applications such as water piping and low pressure refrigeration are the primary uses in HVAC. You also use soldering to put two electrical terminals together or connect electrical wire to a circuit board and stuff like that. But for our purposes, we are talking about soldering pipe. For good capillary traction, there should be a space between the metals of about 0.003 inches. It's a very small gap. Soldering is not a good filler metal. Capillary traction is when the liquid metal is pulled in, or liquid material is pulled into a small crevice on its own, or with a little help, like putting a heat source on it. Solder flows between the two metals with capillary traction. After the tubing has been cut to size and deburred, there's specific steps you have to take for properly soldering a joint. Okay, these steps are clean the parts of the joint, apply a flux to the male connection, assemble the tubing and fittings, heat the joint and apply the solder, wipe the joint clean. All of these must be accomplished. Okay, the end of the copper tubing and the inside of the fitting must be absolutely clean. Even though these surfaces may look clean, they can contain fingerprints, dust, or oxidization. A fine sand cloth can be used. Once the pipe is cleaned, do not touch the cleaned area with your fingers or drop it. You'll make it dirty again. Okay, so once again, what we're doing is we're using 120 grit like emery cloth paper, and we're sanding down that outside. If you can see any areas that are not like the clean metal that you see in this slide, your your pipe is not clean enough. It has to be perfect. Clean the inside of any fittings as well. Use a wire brush or use a rolled up piece of emery cloth to do it. Apply flux as soon as you clean the surfaces. For soft solder, apply the flux with a clean brush. Apply flux only to the area to be joined and avoid getting flux on the piping system. The flux minimizes oxidization and helps flow dirt out of the joint. So again, apply the flux with a brush. You want to always put it on the male end of the fitting. Do not put it on the female components. Okay, you don't need a ton of it, but it just needs to be in there coated properly. Soon after the flux is applied, assemble and support the joint so it's straight and will not move by being soldered. Solder cannot handle moving parts while it is cooling. Okay, it needs to be straight and supported. When soldering, heat the tubing near the fitting first for a short time, then move the torch from the tubing to the fitting. Keep moving the torch from the tubing to the fitting back and forth. Heat the entire joint, not just one side, so the torch is constantly moving. Spread the heat evenly. Do not overheat any single area. Don't point the flame into the fitting socket. Hold the torch so the inner cone of the flame just touches the metal. Continue to test the heat of the metal with solder. Do not melt the solder with the flame and use heat in the metal. When the solder flows freely from the heat of the metal, feed enough solder in to fill the joint. Don't use excessive solder. You don't want it dripping and dropping all over the place. Solder will normally flow towards the flame or whatever your heat source is. Okay, so if you move the flame up a little bit onto the outside of the fitting, it will help pull that solder towards the heat source. For horizontal joints, apply the filler metal first at the bottom, then to the sides, and finally to the top. Make sure that these operations overlap. You don't want to leave any spaces. On vertical joints, it doesn't matter where the filler metal is first applied because it's actually going to flow around. So again, your steps are clean the piping, apply the flux, apply the solder, and then when you're done, as the metal is cooling, as soon as the solder is actually cooled, get a damp cloth and wipe it down. While the joint's still hot, you can wipe it off with a rag to remove excess solder and flux. It's not necessary, but it improves the appearance of the joint, and it makes it look neater. We have one additional type of piping we want to talk about. Hard-drawn copper piping is manufactured to be 10 or 20-foot lengths that are not intended to be bent. This material is commonly used when long, straight piping runs are needed, such as in the installation of a condensate line. If the piping arrangement must bend up, down, side to side, or pipe fittings must be used to create the desired turns or leveling. Pipe fittings come in a wide wide range of sizes and configurations that enable the installing technician to create the desired pipe contour. Whenever a fitting is used, there are at least 2 joints that must be properly sealed. If the pipe and fitting are not sealed properly, fluid or gases will leak from the system. One drawback of using hard-drawn piping is an increased chance that the system will develop leaks due to the increased number of joints in the circuit. The more solder joints you have, the more chances for leak. Remember, our other type of tubing we've already talked about is the soft-drawn ACR tubing. If you can use that at a reasonable cost, and if you have to do a lot of bends and turns, use the soft-drawn tubing because it's going to be much better in terms of the number of fittings you have and the more chances for leaks.